Okay, welcome back. As you can see on the screen, we have the parts that we'll be using as a basis for the machine vision to recognize specific parts that we've already inputted into the program as templates, image templates. The image templates being the worm gear, as I'm indicating using the cursor right now, and the collar. So we're going to attempt to track both of these parts simultaneously while this program is running. It's also prudent to note that we have a minimum match score, which I have set to 1000. This is a very high minimum match score, meaning that the level of detail required is much higher than expected, and it is to ensure that we detect the correct part. We don't accidentally detect any of the other parts that are being displayed on the screen. Now, the camera that we're using is a desktop webcam, and therefore its capabilities are limited. It is unable to zoom, unable to focus, and its image quality is not the highest. So it requires calibration in terms of distance and focus from me. The position of the part in X and Y, the angle, will all be recorded and displayed and used to determine the bounding box and its orientation around the object should there be a match. And to indicate that, there will be a light that goes on, green light. So let's go ahead and attempt to track our parts. So moving the camera forward, moving us at a slow pace to find that correct distance at which point the parts are detected. So far we're moving towards the screen, and the part has not been detected yet. So perhaps we should reduce the minimum match score. We'll reduce it to, say, 700. For both parts. Let us now attempt to detect the worm gear as well as the collar. So we have successfully detected the worm gear. We're tracking it, and we have successfully detected the collar. It's prudent to note at this point that we've detected all worm gears and collar on the image on the screen. We are only able to track 2 parts at a time, so the software makes a decision as to which 2 parts it would like to track. Note that the bounding box is not actually rotating around the worm gear template, but it's rotating around the collar. This is obviously due to the circular shape and the program having trouble determining the orientation of that collar and adjusting accordingly. So we have a match, as you can see by the 2 green lights. You can also see the positions, the angles are being noted. So let's move it back yet again and reduce the minimum match score drastically. Let's bring it to, say, perhaps 400. Let's actually bring it down by half, 350 from detection. And you can already see that there is a mismatch according to our vision, but the PLC is convinced that it is detecting the worm gear However, it's not even in the slightest. It's actually making the image suit the parameters, not the parameters suit the image. And it's continuously detecting very widely. It has successfully detected both the collar and the worm gear, and the bounding box is much larger. It's not as close to the object. If we were to go closer, and now the software believes it's detected the worm gear. However, it's only detected part of a screw. So this demonstration of machine vision using this LabVIEW graphical user interface of the program previously explored in block diagram format, it has successfully shown the capabilities of machine vision and how a program can be written to sense parameters that are desired, but also has shown the limitations and capabilities while we are discussing, as we watch this video, what is right and what is wrong in terms of the actions taken by the software, which can be loaded into a PLC. PLC, or the software itself, is completely unaware and requires calibration and direction for it to determine what is the correct input, what is right and what is wrong, whether it is seeing things correctly. We've also seen that while the camera is moving and the angles are constantly changing and the shapes, size differing, we are actually able to use this software to successfully track an object. So perhaps we can extend this idea further and track a moving object, record the data and write it to file, and use that data to analyze even the velocity or any other parameters of interest with regards to the movement of that object that has been tracked.